In this video, I will demonstrate Excel and POM to solve double exponential smoothing problems. This is a video. This is a video that I've created using the demo problem from the book for MBA MSF 624. If you are taking another class and watching this video, you can just follow it for process. The data is here, you can practice with it. Double exponential smoothing is used when we believe the time series has trend in it. It's a short-term forecasting method because it will only calculate one period into the future. So this problem, we can only compute the forecast for January of next year. So we have 12 months and we can only calculate it for the next month, January. When we use double exponential smoothing, we have two alpha coefficients to use. That's why we call it double exponential smoothing. Alpha coefficient is used for smoothing out the random fluctuations in time series. Beta coefficient is used for smoothing out the trend coefficient, the trend fluctuations in the time series. We start off by computing single exponential smoothing. We have discussed it in previous videos. To start off our analysis, we need a starting forecast. In this book, or in this chapter problem that I'm demonstrating, the value for demand is used as the forecast value. The next forecast and all future forecasts are computed using this equation. So the forecast for any given time period is equal to alpha times the times the demand from the previous period plus 1 minus alpha times the forecast from the previous time period. This will be 37, of course, because both our demand and forecasts in the previous time period were 37. But if I copy this down, notice something happens that we do not want to happen. The reason for that is because when I write this, I need to fix the cell reference for alpha value for this 0.5 so that in every calculation future, it will grab that 0.5. So I need to fix the cell reference. If I put my mouse in there and I click F4, it'll insert these dollar signs. The same thing needs to be done here. And if I enter now, something happened that should, not 4, F4. There we go. So now I have fixed cell reference and fixed cell reference for this 0.5. And I can copy this down, and these are the values that Excel computes for me. Now for trend, we're going to skip over the first month because we didn't do any calculations for it. This 37 was assumed to be 37. To start off our trend analysis, we also need a starting trend value. This book uses a 0 to start off the analysis. To compute future ones, we use this equation. Again, I will fix the cell reference as I'm typing. So we have equals beta, which is this, and I'm going to fix the cell reference, times the forecast from that same time period minus the forecast from the previous time period plus 1 minus beta. But again, I have to fix the cell reference times the trend from the previous time period, which would be this 0. If I show you this now, I can just copy that down, and now I have all of my trend components. The adjusted forecast equals the summation of the single exponential forecast plus the trend. So now I can copy that down. If you are in MBA MSF 624, you can check these results against what's in your book in that demonstration problem. Now, we can use this demand column and this adjusted forecast column to compute error and forecast accuracy. For example, we have, we're not going to include that first month because no calculation was there, but over here for error, we can compute actual minus the forecast, or the adjusted forecast, which is the final forecast. And I can, oops, not this one because we don't have an actual for it. So these are the error factors, or we can, and of course if I average those, this is going to be bias. If I compute absolute error, absolute value of this number, or I can just put actual minus the forecast. Then I have these numbers. If I average them, average there. If I average them, I have MAD. This is MAD. And this one is bias. I can compute MAPD, mean absolute percent error, or mean absolute percent deviation, and that is summation of this is summation of all of the absolute error terms. So MAPD is equal to, and this right here is, I'll put over here, these are summations. So if I'm not including the first period into error analysis, then I should not include that 37. So my summation is going to be 40 to 54. So to compute the MAPD, I can take the summation of absolute errors and divide it by the summation of demand, and I get 0.08. Now I can show you how to do error analysis with Excel. So this is the actual. I've chosen exponential smoothing with trend. I have fixed alpha value to be 0.5 and beta value to be 0.3. And notice that I have started under forecast. I have included a 37. And for trend, I will include a 0. Now with that, which of course if I do this, now they appear. So I'm including a 0 there. And with that, if I solve, I get the same 54.7, which is what my forecast is, adjusted forecast is that I computed. This is my 8 point, this is my 8% due to rounding. This MAPE and this MAPE may not be the same, but it's right around 8%, 8.1% if I round this off. Bias is 1.92 as I computed. MAD is 3.81 as I computed. And so I think, and I can go to Window, Details and Error Analysis, and you have all of these trend column right here, which is right here. You have the adjusted forecast column, which is this adjusted forecast column right here. You have the unadjusted, which is this unadjusted or single exponential column here. So that's how you can go back and forth between the two. You can perform all the calculations by yourself using Excel, given that you can just write the formulas and copy them down. Okay, thank you.